Now, after looking at the theoretical part of the double integral for the Cartesian coordinate system, because mainly we are dealing with the variables x and y, we switch over to the example. Just to remind you that we have learnt earlier the generalized rule for integration by parts. Generalized rule for integration by parts says that integral u dot v dx means integration of product of two terms. We usually apply integration by parts, and applying integration by parts we use Liet rule: logarithmic, inverse, algebraic, trigonometric and exponential. So what does generalized rule says that go on taking integration of second and derivative of the first with alternate plus minus. So u into integration of v minus u dash into double integration of v plus u double dash into triple integral of v, and so on. This is going to stop when this particular derivatives will exhaust or those will vanish. In that case, integration by parts is taken in one stroke. So we need to remember this formula for integration by parts. A generalized rule for integration by parts. We must have learned this in differential equations unit in the previous semester. Now, first example, evaluate the double integral given by integral 0 to 1, integral 0 to x square e to the power y by x whole dx dy. So our integrand is e to the power y by x. Integration is done with respect to x as well as y. So as two signs of integral are observed, I identify this example as an example of double integral, and it is also mentioned. And to be more precise, one of the pair of limit is seen as constant, other pair of limit is seen as variable, as we discussed in the case number 1, case number 2 for the evaluation of the double integral. Now I have to decide the sequence of integration, that whether with respect to which variable I have to integrate it first and later on with respect to which other variable. Let I is equal to the first integral 0 to 1, second integral 0 to x square e to the power y by x dx dy. Now by observation I am seeing one of the pair of limit appearing in x. So that must be representing which variable? It must be representing the variable y. So that means I will have to first integrate with respect to y, and then after integrating with respect to y, the resultant will be term of x, and then later on integrating with respect to x, putting down the constant limits, you get the final answer. So by observation I see the limits in variable x, so opposite variable is y. Integrate first with respect to y, get the answer by putting the limit in the form of x, and then integrate with respect to x, putting down the limits as constant, you get the answer. So this is how the flow of integration will be. So integral x is equal to 0 to 1 and dx is written outside the rectangular bracket. Integration of y from 0 to x square for e to the power y by x dy. As I told you, integration with respect to y, keeping x constant. What is integration of e to the power x? Integration of e to the power x is e to the power x. Integration of x by 2, it will be e to the power x by 2 upon constant. What is coefficient of x? The constant term 1 by 2. Similarly, integration of y by x, I am integrating with respect to y. X is constant. Coefficient of y is 1 by x, which will be constant. Therefore, integration of e to the power y by x is e to the power y by x upon 1 by x, and limits will be put between 0 to x square. That is how integration of e to the power 2x, it is e to the power 2x upon 2. So whatever is the constant term, that is getting divided to the integration. So that is how integral x is equal to 0 to 1 e to the power y by x upon 1 by x, limits to be put between 0 to x square, and whole is to be integrated with respect to x. This 1 by x goes to the numerator, becomes x. Put upper limit in place of y, e to the power x square upon x is e to the power x, e to the power 0 upon x is e to the power 0, e to the power 0 is 1. So it is x multiplied by e to the power x minus 1 dx. Open the bracket, you get x e to the power x minus x whole dx. I am left with the simple integration with respect to x. The integration of the term x e to the power x will be x e to the power x minus e to the power x, the common normal integration, minus, after applying Liet rule you get the answer, integration of x is x square by 2. Put the limit, upper limit as 1, lower limit as 0, your final answer will come out as 1 by 2. So in this case, I understood that whichever variable appears in the limit, उसके अपोजिट वेरिएबल के साथ पहले इंटीग्रेट करना है, फिर बचा हुआ जो आंसर है that will be the constant quantity. The very next example wherein I see both the pair of limits as constant. In this case, order of integration is not important. Either you integrate first with respect to x and then with respect to y, or first with respect to y and then with respect to x. It is not at all important. But in doing so, I have to take care that limits are to be put appropriately. So इंटीग्रैंड क्या दिख रहा है, dx dy upon x plus y whole square, means our function of xy is 1 upon x plus y whole square. Integration of ax plus b to the power n dx is given by ax plus b to the power n plus 1 upon n plus 1 multiplied by a, where a is coefficient of x. So how it is to be integrated? Appropriately taking the power to the numerator and then integrating. अभी मुझे बताइए यहां पर either I integrate first with respect to x और y, वो इंपॉर्टेंट नहीं है, पर कौन से लिमिट कौन से वेरिएबल के है ये पहचानना बहुत जरूरी है. सो outer limit is 3 to 4 and outer differential is dy. So these limits shall represent the variable y. Innermost differential is dx. So these limits shall represent variable x. तो भले मैं पहले y के साथ इंटीग्रेट करूं तो लिमिट मुझे पुट करना पड़ेगा 4 and 3, नॉट 1 and 2. पहले अगर मैं इंटीग्रेट करता हूं x के साथ तो लिमिट पुट करना पड़ेगा 2 and 1. अगर मैं बाद में भी करता हूं इंटीग्रेट विथ रिस्पेक्ट टू x, but limit of x shall be put 2 and 1. This is very important point to be noted. So moving further, for the solution, I write innermost bracket as integral 1 to 2 dx upon x plus y whole square, outside dy, and limit of y will be obviously 3 to 4. This denominator raised to the numerator x plus y to the power minus 2, comparing with ax plus b to the power n, minus 2 plus 1 बन जाता है minus 1. So integration is x plus y to the power minus 1 upon minus 1. इंटीग्रेशन विथ रिस्पेक्ट टू x कर रहे हैं, y कांस्टेंट रहेगा, सो x प्लस b के फॉर्म में इंटीग्रेशन होगा. कोएफिशिएंट ऑफ x is 1, no need to divide by any of the quantity in the denominator. Put the limit 2 and 1, आपका माइनस कॉमन निकल गया. This negative power brought to the denominator with the positive power. अपर लिमिट इन प्लेस ऑफ x अपन पुट करेंगे 2, तो 2 प्लस y मीन्स y प्लस 2. 1 पुट करेंगे तो 1 प्लस y मीन्स y प्लस 1. माइनस से मल्टीप्लाई करो तो 1 upon 1 y plus 1 will be the positive term, 1 upon y plus 2 will be the negative term. Integration of 1 upon y plus 1 is log y plus 1, because integration of 1 by x is log x. So integration of 1 upon y plus 1 is log y plus 1. Integration of 1 upon y plus 2 is log y plus 2. Upper limit to be put is 4, lower limit is 3. By logarithmic convention, log m minus log n is log m by n. Y plus 1 upon y plus 2. Put upper limit as 4. 4 plus 1 is 5. 4 plus 2 is 6. Log 5 by 6. Minus lower limit 3 put करेंगे. 3 plus 1 is 4. 3 plus 2 is 5. Log 4 by 5. Again, log m minus log n. Log m by n. Log a by b upon c by d. A by b upon c by d, and a division gets converted to multiplication and reciprocal of the denominator. So a upon b into d upon c. 5 by 6 into 5 by 4. Log of 25 by 24 is the final answer. So